If you went to the bank and gave them 1,000,000 quarters and asked for dollar bills back in return, they'd probably look at you like you were crazy. But they could do it. And there wouldn't be a single employee in that entire bank that would count out each of the 1,000,000 quarters. Instead, they could find out exactly how much money was present by weighing all of the quarters that you gave them. Because if they knew the mass of a single quarter, they could figure out the mass of 1,000,000 quarters as well. And that would give them a clear indication of um, how much money you presented without counting them, just by using kind of precise measurements of mass. Well, in chemistry, there is a very similar concept. It's called the molar mass, and it's the mass of 1 mole of a substance. Let's say that I wanted exactly 1 mole of copper metal, and I know that that would require counting out 6.02 times 10 to the 23rd atoms of copper metal. And I've told you in a previous video that the idea of counting out this number of atoms, it's impossible. It would take way more than your lifetime, and you would have no chance of actually counting it out. But here's the beauty of how that number was designed. That number, 6.02 times 10 to the 23rd atoms, actually represents the number of atoms in exactly 63.546 grams of copper metal. And so if I were to place some copper onto a balance until that total came up to 63.546, I would know at that moment that I had 6.02 times 10 to the 23rd atoms, and therefore 1 mole of copper. That's what we call the molar mass, or in this case, copper would have 63.546 grams in 1 mole, grams per mole. Okay? And what's beautiful about how this works is it changes for each element, because each atom of each different element has a different mass. So if I did the same thing with silver instead of copper, I could not weigh out 63.546 grams of silver. I would need to weigh out 107.8682 grams. And if I did that, if I weighed out 107.8682 grams of silver, I would have 1 mole of silver. I would have 6.02 times 10 to the 23rd atoms of silver. So that leads us to a number of different calculations that we could do. What if I didn't have 107 grams of silver? What if I only had 23? And I wanted to know, how many moles of silver is that? Well, anytime I'm going from grams to moles, I am not using the word atom at all. So I know the number 6.02 times 10 to the 23rd isn't going to be involved in this calculation. Instead, I'm going to use molar mass. And here's how I would do that: 23 grams of silver. I know from the periodic table that there are 107.86, let's call it 107.87 grams of silver in 1 mole of silver. I use the molar mass to complete this particular conversion. So on my calculator, I'm going to say 23 divided by 107.87 0.87. And I get 0.21 moles of silver, just like that. I think you should try a problem. Why not do this? What if you had 402 grams of gold? How many moles would that be? Hit the pause button on this video and then come back after you're done and see if your answer matches mine. Okay, welcome back. So I do this problem the same way. I find the molar mass of gold. It's 196.97 grams of gold for every 1 mole of gold. And so on my calculator, I'm going to say 402 divided by 196.97, and I get 2.04 moles of gold. That's it. Let's do one problem going the opposite direction. What if I had moles but was looking to find out how many grams were present? Let's say I have 6.71 moles of copper, and I want to know how many grams of copper that is. So 6.71 moles. Need to specify which element, copper. Now I'm going to use the molar mass to get to my number of grams in 1 mole. Moles goes on the bottom, so it cancels out. There are 63.55 grams of copper. On my calculator, I'm going to say 6.71 times 63.55, and I get 426 grams of copper. Okay, we have one last conversion type coming up after this. We're going to save it for the next video. We will see you